high caliber panel here, and it's open Q&A, but I just want to jump right in. Yeah, Taproot's activating soon. Definitely going to ask Pieter when that is. I believe he has it off the top of his head. And then also, perhaps what happens now when it activates? How many clients are ready to use Taproot, and maybe how many aren't? How does it work on a peer level? Let's jump right in.
I believe in November 14th, so in a couple days. Maybe someone else knows it more accurately.
I just passed it.
There you go. The Taproot activates at block 709632, which is approximately November 14th, maybe earlier by a day or so, because blocks don't come at a consistent time.
Oh, my mic. Oh, okay.
No, sorry.
Okay. All right.
So the next question was, I don't believe all of the network is running 21.1 or Bitcoin 22. What happens?
Well, hopefully the miners that have been signaling readiness are actually going to enforce it. And if not, there is hopefully a lot of the upgraded nodes that are the economic actors in the space. So even if there were more nodes that don't enforce it yet, the economic majority would be.
So in short, all upgraded nodes or otherwise Taproot compatible nodes as of block 700 and that number ending in a 2 will start enforcing these additional rules around Taproot validation. They're exactly the same as the rules before, except some things that used to be undefined. So automatically valid scripts will now actually be the Taproot validation rules will be applied to them, and they will be enforcing it. And if transactions or blocks are relayed on the network which do not follow those rules, they will be rejected. And the theory is that this pressure by hopefully a economically relevant subset of the network enforcing the rules is sufficient to incentivize miners to enforce the rules as well.
And also any nodes that don't enforce the Taproot rules would see the Taproot transactions as non-standard and wouldn't add them to their mempool or forward them. So presumably, if everybody runs standard non-malicious code, they'll just ignore everything they don't understand. I think. Yeah.
Could you walk us through what would happen if a bunch of these miners were all lying and they don't actually enforce this? Like a strong majority didn't enforce? Like how does that actually play out?
I mean, as long as nobody creates a malicious transaction that tries to break the rules of Taproot, that wouldn't actually be a problem, because the non-Taproot blocks are still valid blocks after Taproot activates. It's a soft fork, so as long as they just run standard code, that's fine. If somebody actually tries to spend a Taproot invalid transaction, then we'd find out.
Possibly not, because honest old miners would not include such a transaction even. So even someone just trying to broadcast it wouldn't be an issue. But of course, that's not something we should count on.
So it's pretty remarkable how, I guess maybe, earlier in the year we were going through locking on timeout stuff, and I guess we're almost in the final stretch with speedy trial. Wanted to get your guys' quick thoughts. Like, are we happy now? Like, maybe is this useful in the future again? Other ideas, general comments?
I think speedy trial has been a pretty big success, even though there were some complications on figuring out the exact details we wanted. It's turned out so far to not have any major issues, and we're not expecting to see any problems with activation once the activation height is reached.
Yeah, I like it.
I think we should use it again. It's very convenient to see early on whether the activation locked in or not, and well, hopefully, one of the things that I'm still curious about is whether the signal of the miners that are now still signaling that they're ready actually turns into enforcement, but which is hard to tell right now. But other than that, I think it's been a great success.
Maybe you could just for context, maybe we could explain what speedy trial is. So that my understanding is it basically allows you to put a delay between activation and signaling, but there's also a way to back out if things seem to be going wrong.
So speedy trial. So the activation mechanism we have used previously for CSV and SegWit was called BIP9 version bits. Speedy trial is a modification to this, where we have the start time. The start time of the first signaling period was really soon after like the parameters had been finalized, and this allowed us to then see very quickly if nodes and miners were upgrading and then were starting to signal for Taproot. And one of the other key features in the speedy trial is that we added a minimum activation height. So this allowed us to delay the activation to a height in the future once signaling there was enough signaling and the software had locked in. So what this allows us to do is we can see whether Taproot would fail really early on, and if it would fail, then it would fail quickly, and we could try a different deployment method. So I forgot to mention the end time. So the end time for the signaling was also fairly short. There was a whole period of about 3 months, but we activated it in like 4 weeks.
Yeah,
it was like the lock-in was after.
Was it the second or third signal?
It was like the second, or, yeah, it was the third, I think. Anyways, we have a minimum activation height so that in between the lock-in time and the actual activation time, that's when everyone can upgrade. Everyone knows that Taproot's going to happen, and so they can be ready by the time we reach that minimum activation height. And so for Taproot, that minimum activation height is that 709,000 whatever.
So here, a small call to action if you're running a full node and you're not running 0.21 or 22.0 or a newer version than that, you might want to upgrade when you get home immediately.
Oh, go ahead.
Is Taproot activated on Testnet yet?
Yes.
And on Signet as well.
Ben, you want to talk about, I guess, the activation that... Oh, go ahead.
Cut off again. I just want to ask, is there a client I've been kind of hunting around that will actually be able to use Taproot on the block that Taproot gets activated like next week or whenever it is?
So Bitcoin Core will, it requires some manual configuration.
Okay.
You need to import a Taproot descriptor manually, so it's not possible through the UI, but through RPC commands you can construct a Taproot wallet that should be able to receive and spend. So, wait, let me rephrase the question. Do you mean have the ability to send to Taproot addresses or actually be able to receive? So
well, I guess either really, but the ability to create a Taproot UTXO.
So
like so I would send it to I would send it to myself.
So receiving is the harder part. So that is about the ability to construct an address that you can give to others, a Taproot address that you will know how to spend from. So there you need actually a wallet that has the Taproot signing and spending logic. And so Bitcoin Core will have this, I think a couple others too, not too many. And it's a manual process. I think the idea is that this will be made default, but only after activation has happened. There's no...
You also can't do it until activation has happened. There is a lockout for that block height to avoid people losing their money.
Yeah.
So there's actually, we're tracking software projects that have already upgraded on a page on the Bitcoin wiki. It's the Bash 32 adoption page. I've posted about this a few times on Twitter, but if you just look at on the wiki, it should be one of the pages that has been edited lately.
Oh, awesome. Thanks, man.
And on the sending side, you're looking for Batch32M support, right? So there's a new address format.
Okay.
Murch, can you quickly talk about, I guess, the incentives of like spending versus receiving with a Taproot address UIs?
We will have a new address format for pay-to-Taproot outputs, which is Bash32M, and the addresses for that will have 43. Sorry, the output size for that will be 43 VBytes. So it's slightly bigger than pay-to-witness public key hash, the single sig native SegWit v0 format. However, on the input side, it's 10 VBytes smaller than pay-to-witness public key hash. So the old single sig native SegWit addresses are slightly smaller to create, but slightly bigger to spend, and Taproot is the other way around. So, do you really? Yeah. Okay. So
That's what you wanted to hear.
If you're spending at high fees and you're creating a change output to yourself, you might actually choose to use the old format because it's only 31 bytes to send to yourself, and then spend the input, which you pay more for, at lower fees later. But if you're sending to receiving from somebody else, you'd want to give them a pay-to-Taproot address because they pay for creating the output and you save the money on spending it later because the input is smaller.
I would also add that if you're doing multi-signatures or anything, you want to switch to Taproot rather than using like or SegWit. I guess there's not really any difference if you're using a pay-to-script hash like WSH versus Taproot. I think there's no difference.
Well, Taproot, if you can do a keepf spend, it's cheaper, but then it depends on what script you're exactly trying to spend.
It really depends on what signing logic you have, and of course, initially there aren't many implementations there, but say you have a threshold-based signature scheme, which is totally feasible, you absolutely want to upgrade.
Once Taproot is activated, I'm gonna explain like I'm 5. What are some things that are going to come as far as like, I know TapScript and Schnorr signatures are coming, but like what implications does it have for the protocol? Like what are some things that'll be possible day one on activation? And also what are some things that you guys see coming in the future that'll take advantages of these changes that aren't really like being built yet?
So it all depends on your wallet. Like if your question is from the perspective of a wallet developer, well, as soon as Taproot activates, they will be able to make use of the features that Taproot introduces. If you're just using a wallet, well, you are restricted to whatever your wallet can do. So there is no impact on as a wallet user, there is no impact on you unless you update to a wallet that can make use of these features.
More generally, so first you'll see transactions that make use of Schnorr signatures. Schnorr signatures are slightly smaller than the current ECDSA signatures, so there is a small savings there for the inputs. If you are involved in multisig, multisig that uses k of k keys, so 2 of 2 or 3 of 3, can be expressed as a tweak in the key path. So when people implement a public key aggregation method, like for example music, they'll be able to do key path spends, and multisig wallets will be able to look the same as single sig on the wire. And I know for a fact that a few companies are working on this already because it'll be huge savings compared to having an actual multisig script in the transaction to just have a key path spend.
So yeah, go ahead.
Good. We'll move on to Lightning at the end.
Okay. More generally, I mean, this is the design goal of Taproot, that it introduces a new address type that can be used for everything. So before we had separate output types, separate addresses for the simple pay to pubkey hash style things, and on the one hand, and on the other hand, P2SH, P2WSH for the more complicated script things. Taproot allows you to produce a single address that is different from all of the ones before, but it can be used by everything. And even better, at spending time, in many cases, you cannot distinguish what it was. So this is both an efficiency saving because it's cheaper. It's also privacy saving because you're not revealing to the world what kind of wallet construction you were using.
So, for example, right now you can detect like there's some fairly large multisigs that are basically only used by one entity. And so you can very trivially detect like, oh, all of these, I don't know, what's the liquid policy now?
9 of 15?
Like 9 of 15s, like all of the 9 of 15s are liquid, basically.
11
so
of
you
15
can, like,
or
11.
2 of 3.
Okay, well, whatever. And so you could hide some of that policy, so you wouldn't necessarily reveal that when you spend the transaction.
Another thing that's a little bit down the line, but a cool crypto trick you can do with Taproot is you can produce a ring signature over all of the Taproot outputs or all of your Taproot outputs above a certain threshold and prove that you are holding a coin of a certain value without revealing which one. Other than that, it's one of the Taproot ones.
Yeah, so generally that kind of fits into a broader category of like Schnorr sigs are much simpler mathematically. And so there's a lot of cool tricks you can do like that and other stuff, like the signature aggregation and whatnot. Excuse me. And then also with Lightning, this is also something that's kind of further down the line, and there's no real concrete. I guess AJ has one concrete proposal for it, but eventually we're going to get PTLCs instead of HTLCs. So instead of using a hash, we can use public keys and revealing the private key for it, or revealing a signature and an adapter signature for it. And that allows us to decorrelate payments across hops, right? So right now, if you go to send an HTLC or you go to send a payment in Lightning, it goes through 4 hops, and all of those 4 hops see its payment hash, ABC, and they all see the same payment hash, and so later they could, get together and correlate and say like, hey, I saw a payment hash ABC. It's like, yeah, I saw that too, and you can correlate and tell where that payment maybe came from, where it went to. And with PTLCs, there's an additional blinding factor added at each hop, and so you can hide, so they won't see the same data, and only kind of their immediate peers will see the same ID. So if you're missing a hop, you won't necessarily be as able to correlate that. So it's one fewer correlation metric. There's obviously other time-based correlation metrics that are problematic, but like the on-chain stuff, it's one fewer correlation metric where you can group, certain types of transactions. There are other issues, but, remove one at a time.
I'd say the explain like I'm 5 is just like standard user wallet is basically the same, and then all the fancy stuff gets cheaper once actually people build all the stuff.
I think that's a good summary. What will change on activation time for a normal wallet user is absolutely nothing until their wallet starts making use of it.
And just what about the script, the tap script? Because was that covered, or am I just too like a normie to know that it was not covered?
I guess we didn't really touch on it. So under Taproot, the script semantics are changed somewhat to permit things like batch validation and a certain number of design goals. But that too doesn't affect you until you start using Taproot. So if a wallet developer who was using more than a simple payment in the past did that in a certain way with script, they will need to do it slightly differently once they want to do it under Taproot. But again, that will be something you only notice once you start using Taproot. None of the rules affecting the spending of non-Taproot outputs is in any way changing.
So Andy, what's up in PSBT land with Taproot? I think there's like another BIP or something, right?
There's a BIP 370, I think. 370?
371.
I think it's 370, which specifies a bunch of new fields that we can use in PSBT for all the Taproot things.
370 is PSBT2.
Maybe it's 371.
think it's 371.
I don't remember. It's just numbers. So the Taproot field, because Taproot is basically completely different from the existing stuff on Bitcoin, there are several new fields to handle Taproot scripts, Taproot, the Taproot tree, the control blocks, key path spans, all that stuff. And so these are just new fields added to PSBT so that once Taproot activates, you can use PSBTs with your Taproot spends. And because of the way that PSBT is structured, software that doesn't understand these fields will still be able to read the PSBT, and if they're trying to sign for a Taproot input, I mean, they shouldn't if they don't understand Taproot, but otherwise they can just ignore those fields.
Plus, it's worth adding, like, Taproot adds a variety of new possibilities, and many of those things will require further extension because, like, we can talk about a wallet supporting Taproot, but what that means is essentially undefined because what aspect are you talking about? Are you just talking about single key? Are you talking about some form of multisig or even more complicated constructions? And so every wallet will probably select its own subset of features that it tries that it cares about, and some of those will require further extensions to PSBT, and in particular Musig.
Ben, more from like an app dev perspective, do you see any efficiencies gained that are useful for perhaps like coin joins and DLCs?
Yeah, I mean, like, we've been hyping this up because things like DLCs or like Lightning, they get cheaper and more private with the Music edition. But as well as like things like ring signatures, that can make you can do cool properties where and you can like create proofs that are even more private that you own this UTXO and stuff like that. I mean, a lot of it's just like Taproot's like finally being like it became a for sure thing like 6 months ago or not even. So a lot of the ideas are kind of out there, but no one started actually implementing them or even like doing the full research to see what we can do because it wasn't guaranteed yet.
Got a question.
It seems like the Taproot supersedes a lot of the old ways of how you would implement things, but obviously we can't forget about those old ways because that's not how Bitcoin works. Are there, from a software development perspective, are there ways that Bitcoin Core can be simplified so that it feels like a growing maintenance burden every new concept we add, even if the new concepts are better than the old ones? Like, how do you guys approach that?
So, no, unfortunately, I don't think we can ever remove any script features, maybe in a very far future, but there's a sort of an expectation that transactions that were valid once remain valid forever, and I think that's an incredibly valuable property that we shouldn't touch. And I would hope would not be accepted by the community if such a proposal was made. But I think it's worth adding that in terms of implementation, there is a fairly good encapsulation of what that is. So it's like, if this output is a Taproot output, run the Taproot routine, otherwise run the old routine. And there isn't so much complexity in interaction between these two. So of course there is a maintenance burden in that, well, there's more code now, but it is, I think, one of the better isolated pieces of code that don't interact too much. Most of the complexity in the implementation is things like pre-computing additional values that need to be passed through in a certain places.
I will say, as an app dev, it's going to be very annoying. Like, all of our stuff is like built on the foundation of like ECTSA SIGs and SegWit v0, and now we're going to have to like have that and then generalize it so it can support the other type too, and that's going to be a lot of work that I don't want to do.
From the perspective of somebody that starts out now to create a new wallet, I think it's very interesting that they only really have to implement this new output type. Maybe right now at the beginning, not all the wallets will be able to send to pay to Taproot outputs yet. because they don't speak Bash32M yet. But I think that we'll hopefully have much quicker adoption than, for example, with native SegWit addresses. With Bash32 addresses. And then when you, for example, start a new wallet now, you only design it with pay-to-Taproot outputs, and you have to be able to send to the old ones, but you don't have to be able to sign for them.
Yeah, so what I was talking about before was just the validation logic. This is a very good point, that wallets can choose what features to implement. That can mean not implementing old style spending.
So Murch, basically, we'll get Taproot addresses on blockchain when we get cross-signature input aggregation about to be activated. Matt, how do you think about this more from like, I know you're working on LDK stuff, like how do you, I guess maybe what are the exciting things? I know we talked about PTLCs briefly. Would Bolt 2, 3, and I believe 7 need to be changed? Are there other Taproot efficiencies gained via gossip, like anything like that?
Yeah, Lightning basically has to be overhauled for PTLCs and for Taproot on chain. So I mean everything. It's going to be a ton of work. So not just adding Schnorr signatures. Like some wallets get to just add some limited stuff, but like you point out, gossip. So right now in Lightning, to announce to the world that you have a channel and that you want to route through it, you point specifically on chain to the UTXO that you have. And then you provide a signature for it. So you say, like, here's my ECDSA signature for that output. So, of course, you can't provide an ECDSA signature against a Taproot. I mean, I guess maybe you could, but we have Taproot outputs, and they've changed the format. And so now we're going to have to change all of the gossip. And then you get fun questions like, do we try to make it more private? Do we do some kind of ring signature over these outputs so that you don't have to tell the world exactly which output is yours versus others? So there's a lot of exciting things, but they're a long ways down the road just in terms of the amount of new code and kind of design overhaul that's going to have to happen to get there.
Andrew, I know you don't like necessarily reveal policy now with the way Taproot is done. Are there any possibilities now with your favorite scriptless scripts?
So there are two things that I do that will be strongly affected by Taproot. One is miniscript and the other is scriptless scripts. And the story for miniscript is similar to the story for Lightning, which is like some pretty dramatic changes are coming to the way that we have to think about scripts and reason about things, and the data structures that we use and where do we use them and what new functionality do we add. And we're certainly farther along than the Lightning Network by dint of having like 0.1% the complexity. But I still can't say exactly how that'll shake out. The other thing that I do though is scriptless scripts, which is ways to encode scripting policy kind of behavior in signatures themselves. And Taproot makes that much more possible in a couple of ways. First of all, just by having Schnorr signatures instead of ECDSA, because it's a real pain to do multi-signature ECDSA signatures and to sideload information into ECDSA signatures and stuff, because there's a modular inverse in there. And there's a multiplication of two pieces of secret data by each other, and it's just hard. Multiplication is hard to deal with relative to addition. And then the cool thing about Taproot is not only does it include Schnorr signatures, but it really puts them front and center so that the normal spending path in a Taproot output is the one where you reveal a Schnorr signature. So if you want to do, I guess if you have the ability to take advantage of these cool scriptless script kind of constructions, like the one used in PTLCs where you can embed a secret data in a piece of secret data in half of a multi-signature, then you're incentivized to, basically. You're incentivized to do it on the chain because you will get a privacy boost by making your channel open or close or whatever look like any other transaction, and also a scalability boost because Taproot is so biased towards single key, single signature spends. So scriptless scripts have been kind of something of a theoretical project. I know like Connor F and some others have been trying to do this in practice with ECDSA, but with the activation of Taproot, suddenly like the people who are less reckless can actually start building this stuff.
Maybe
exciting.
a bit more practical. Like so, one of the things you can do with this is an atomic swap of two outputs on chain, where it's basically a privacy technique where you have a coin and I have a coin, and we do transactions on chain, but there's no linkage between the two. Like we swap. It's equivalent to us swapping our keys, and so you don't see which one goes where. And while this was already possible, this was made difficult for two reasons. One, you need ECDSA multisig implementation, which is complicated, as Andrew explained. And secondly, there was no way to make these transactions look like normal payments, because they'd have like a timeout clause that is just obvious. Oh, okay, after some time things go back to the owner. And with Taproot, we can hide that timeout clause.
So it looks like we're almost out of time, but I'd like to go back to Murch for a final kind of analysis. I know he offered to assist companies in output management, fee select or coin selection, fees, just as general perspective. How does Taproot affect this, and like just managing your UTXOs?
Yeah, I think that especially for a lot of the enterprises who use multisig, Taproot's going to be super interesting. I've talked to a couple companies already, and they're working on putting stuff into tap trees, and they have some minor savings there already potentially, but really down the line when they are finished implementing music and then using the key path for the most common case, they'll maybe even reduce their input sizes by like 40 something %. And really excitingly also, then they'll look like single sig payments, even though they're multi-sig under the hood. And yeah, if we can reduce the number of bytes that we need to express stuff on the blockchain, there's more space for everyone. So we might have some good low fees for the remainder of the year.
Exchanges, please give them a call. I think that's about it. Anyone else have any last minute questions? Hey, I think we're good. Thank you guys.